Yes, recording has started. Okay, guys, so I'm hoping this will be quite a quick one today, and that will allow us time to go back and carry on with yesterday's tricky one, okay, which I don't think anyone had finished and got 15 out of 15 on. Even if we don't get a chance to go back today, tomorrow's lesson, which is our last lesson before half term, I'm going to make a catch-up lesson. So I want you all still to come on live, but there won't be any more new teaching. It will just be an opportunity to finish off any of the Dr. Frost exercises that you haven't finished yet. Okay, so everyone can start off with yesterday's. But for today, I just want to introduce you to this little topic here, okay, called correlation and scatter graphs. So imagine you've got two things going on, what we'll call two variables. Okay, so let's say we've got a child's height and a child's age. So if we go and put the child's age at the bottom, let's see what sort of lag we've got. So child's age will go along the bottom. Oh, that's not too bad, is that a few seconds? And let's go and say a child's height is on this side. So imagine you're just going around school and you're just measuring everybody's heights. Okay, so you go into junior school and into some of the reception kids who are 1 or 2 years old and they hardly got any height at all. They're really short. Okay, so you might have a few down there. Okay, and then you go into sort of a junior school, but the bigger kids, sort of year sixes. So they're all going to be about 10 and their height might be around there. So you measure the heights of a few. And then you go into senior school and you go in and you measure lots of heights, again, of the older kids. And of course, you're going to get some kids in junior school who are really tall, and you're going to get some kids in senior school who are quite short for their age. But generally speaking, there will be a trend that the older the kid, the taller they are. Okay, and you can see from what I've drawn in that diagram, there is a general trend upwards. Okay, and we'll come on to what's that called. But generally speaking, those points are going in an upwards direction. Okay, so let's just go and have a look at the various ones we could have on the right. So that's the one I've done, a child's height as it gets older. You know, a fish's weight as it gets longer. So you might have the length of a fish along the bottom and how much it weighs on the side. And generally speaking, the longer the fish, the heavier it will weigh, and so on. So we're understanding the relationship between two variables, so two things that change. So a child's age changes with time and its height changes as it grows. So let's go and follow. We're just going to do one example, okay? And I know it's very small, but bear with me, and I'll just try and read it on the right-hand side. And on the next slide, you'll see that it. On the next slide, you'll see that I've made it a little bit bigger to see. So the height in centimeters of young tomato plants were measured, and the number of leaves on each plant was counted. The information is below. So we've basically been measuring the height of tomato plants and how many leaves they have. And I don't know how familiar you are with tomato plants, but as they grow, they sort of grow more tomatoes, they grow more leaves. So let me just start plotting these. So the first tomato plant had a height of 6 and had 1 leaf. So I've gone to a height of 6 and I've plotted 1 leaf. Okay, it's just come through in a second. A height of 6, and so I've gone 6 along the bottom, and then I've tried to go 1 up. Okay, let's change colour for the second tomato plant. Oh, I haven't changed colour. Let's try and change colour now. Okay, so it's got a height of 28 and 16 leaves. So that's quite an old one. There we go. And I would just go and plot all of these plants, all of these points. Okay, so how to draw a scatter graph? Well, we work our way along and draw all the points on the graph. And you will see on the next slide that I've already done that ready for us when we turn over. Okay, but back to this slide. So what do? We draw suitable axes and label them. That's what I've done here. We've got height along the bottom and number of leaves along the top. Okay, we plot the points carefully. And when we've plotted them all, what we go and just try and see the general trend. Now, here it says in purple, we draw an oval around all the points, excluding any obvious outliers. So what we're saying here is you might get one point that is completely out of the ordinary, okay? And you wouldn't really want to let it affect your overall decision, okay? You might have somebody in junior school who's just really hugely tall, okay? So you just wouldn't really want to let it sway your overall decision making. So with this one in mind here, can you see on this slide, on the next slide, as it clicks through, there's that one tomato plant there, which is just really weird, okay? It's really tall, but it's hardly got any leaves. So maybe it's been attacked by an animal or something, okay? So you wouldn't really want that to affect your decision. So we're just going to be looking at all of these points that I'm just popping in an oval shape there. They're the ones that we're going to be focusing on, okay? So what do we have to do? We determine we draw an oval around it, excluding any obvious outliers. So ignore any that are breaking the trend. And then you draw a line of best fit. Try and make sure there are as many points above the line as below it. So what we're saying there is, and this is not very mathematical, you're just doing it by eye. So you get out your ruler and you just try and draw a line going through those points, something like that, where you've got as many points above it as below it. And that affects the general trend, okay? Notice how it doesn't have to go through the origin. Notice how my graph doesn't go through this point here. There's absolutely no need for it to go through where I've just placed that red arrow on the left. And I've just by eye, I've gone and popped in a line of best fit, but I haven't taken into account that outlier. I'm not worried about that point. I'm just ignoring that. My orange line isn't coming down a bit to take into account that outlier. Now, once I've got this line of best fit, that orange line is called a line of best fit, I can then use it to answer questions. So the question might be, using your line of best fit, how many leaves would you expect a tomato plant to have if it's 16 centimeters high? So I would go to 16 centimeters high. I would go up and hit my line of best fit, and I would go and see how many leaves I expect it to have, and it would be about 7. Alternatively, the question might say, I have a tomato plant that's got 14 leaves. How high would you expect it to be? So I would go and find my 14 leaves, and I would go along and hit my line of best fit. And I would go and see how high I would expect it to be. So that's my dotted green line. So with my green line, I've been given the number of leaves and I'm estimating the height. And with that red dotted line, I was given the height and I'm estimating the number of leaves. But note how I've based that on the line of best fit in orange. I've gone across, or I've gone up and I've hit that line. You must put in a line of best fit. Just don't go along to the middle of the exit or the crosses you've done. Now, one final thing to introduce you to, it's what's called correlation, okay? Correlation. It's the relationship between the variables. Now, if it was like a child's height and its age, like the one we just did, where the points are generally going upwards like that, all right, and we put in our line of best fit, this is called positive correlation because we're going upwards, all right? So where the points are generally going upwards, so our line of best fit is going upwards, that is called positive correlation. And you will see on your Dr. Frost worksheet, you'll have some points going upwards or downwards, and it will ask you to describe the type of correlation, and you just say positive or negative or whatever. Now, it may be that it's the other way round. Imagine we've got something where we've got, say, temperature across the bottom, and you run a shop that sells coats, for example. So we have coat sales going up the side, okay? Now, when it's very cold, all right, you are going to, no, is that the right way around? Let me just think. When temperature is cold, you're going to stop. Yes, that's right. So when it's really cold, like a day like today, so it's nearly freezing. So say the temperature is really small at the bottom. You might sell loads of coats if we weren't in lockdown. All right. However, when it's boiling hot in the summer, a nice summer's day, and it's, you know, everybody's out in their shorts and their t-shirts and everything, you're not going to be wanting to buy coats. You're going to be buying ice creams and stuff. So when the temperature is high, the number of coats you sell might be really low. And we're going to have everything in between. So when you put a line of best fit in on where the relationship between the variables is something like that, the general trend might be downwards, and that's called negative correlation. So upwards positive, downwards negative. Now, you might have something where there's absolutely no relationship whatsoever, okay? Let's go and say, oh, I don't know, Theo goes and does some keepy-uppies, all right? He's a good footballer, all right? And that's one of them. So the number of keepy-uppies, I just write keepy-uppies, along the bottom, and going up the side, it could be the number of goals that Man City scored in a game. Now, they are just not related at all, okay? They're just completely separate things going on in two different parts of the country. So if we were going to go and plot, the points there would just have no relationship whatsoever. There would be no general trend upwards or downwards. It would be all over the place. And that's when we say there is no correlation. Okay, so where there is a relationship between the two variables, and as one goes up, the other goes up, that's the green one. That's called positive correlation. Where there's a relationship that as one goes up, for example, temperature, the other one goes down, for example, coat sales, that is the red one. That is called negative correlation. And then you might have one where the two things just aren't connected at all. That's the black one. That is no correlation. So that's it, folks. So I know I talked for quite a long time on that, but I think once you got to grips with it, it's not that bad. OK, now I think with what I've done with the worksheet, because we're doing it remotely, I think on the whole, the lines of best fit have already put in. So you've just got to go and use it to go and estimate information. So good luck with that. I will go and stop the recording now. OK. It would be great. It would be lovely. It's really good. It makes me feel happy if once I've stopped the recording, lots of you have got your cameras on, just so I feel I'm just not talking to a blank screen. So I have stopped the recording now. So the more of you who could put your cameras on now, the merrier.